This is what you picture when someone says the edge of the solar system. And this is what is actually out there. 12 places past Mars, and almost none of them look like the picture in your head. One has never been seen by any telescope ever built. And one of them we are still hunting. A planet bigger than Earth that should be out there right now, and nobody can find it. Every distance here is an AU. 1 AU is Earth to the Sun. Hold on to that number. It is about to stop meaning anything. Start where every movie starts. The asteroid belt. You know the shot. A wall of tumbling rock. A ship weaving through it, near misses on every side. Now the reality. If you were dropped into the middle of the asteroid belt, you would almost certainly see nothing at all. Not one rock. Add up every asteroid in it, all of them, every last one, and you get about 4% of the mass of the moon spread across a ring 1 AU wide. It is not a wall. It is an empty room with dust in it, and it is still not the edge. But there is one thing in that empty room worth stopping for. Ceres, 940 kilometers across, round under its own gravity, and it holds somewhere around a quarter of everything in the belt by mass. When the Dawn spacecraft arrived, it found bright patches on the floor of a crater called Oort, the brightest spots on the whole object. They are salt. Sodium carbonate, left behind by briny water that pushed up from below and evaporated, which means Ceres is not a dead rock in the asteroid belt. It is a world with liquid still moving inside it, sitting less than 3 AU from home. Skip out to 30 AU and you hit the same trap, on a scale that is hard to hold in your head. The Kuiper Belt holds hundreds of thousands of icy bodies over 100 kilometers wide and more than 1 trillion comets. And if you add all of it together, every body, every comet, the whole belt comes to no more than about 1/10 of the mass of the Earth, spread through a volume so large that the things inside it sit impossibly far apart. You could fly a spacecraft straight through the densest part of the Kuiper Belt and be extraordinarily unlikely to pass near anything at all. We have done it. Twice. Neither probe had a single thing to dodge. Pluto earns its place. That bright heart on its surface is not a marking on the ice. The western half of it is Sputnik Planitia, a sheet of frozen nitrogen, 1,000 kilometers across and about 4 kilometers deep. And the shape may not be geology at all. One model says it is a splat, a low-angle impact, an object around 730 kilometers wide, coming in at 30 degrees, hitting and smearing like a water balloon skipping across pavement. There is a competing model that says it is a subsurface ocean pressing up from underneath. Either way, the mass sitting in that basin was enough that Pluto rolled. The whole world reoriented about 60 degrees to put the heart where it is now. And it is still not the edge. Now, step off the mat for a second, because the next boundary is not a place. In 2006, at a meeting in Prague, 424 astronomers voted on Resolution 6A, a definition of the word planet. 3 conditions. It has to orbit the sun, it has to be massive enough that its own gravity pulls it round, and it has to have cleared its orbital neighborhood. Pluto passes the first 2 and fails the third. That is the whole story. Pluto was not demoted for anything it did. A category was written around it, and it fell outside. And the third condition has critics, including the man who ran the mission that finally photographed the place. Eris is the reason that vote happened. Found in 2005, out past Pluto, and at the time, it looked bigger. You would expect a bigger Pluto. It is slightly smaller. But it is 27% more massive, far more rock, far less ice. And it has one of the most reflective surfaces in the solar system. It throws back about 96% of the light that reaches it. Fresh snow reflects less than that. It would still look like deep twilight if you stood on it, because almost no light gets that far out. The reason it reflects like that is that the surface is its own atmosphere, nitrogen and methane that freeze out and fall as snow when the orbit carries it to 96 AU, then lift off again on the way back in to 38. Where that methane came from is still open. One reading says it leaked from a warm interior. Another says it has been sitting there since the solar system formed, and it is still not the edge. And now the one we cannot find. In 2016, two astronomers at Caltech looked at the 6 most distant objects known at the time and found their orbits clustered, tilted the same way, leaning the same direction, as if something large out there were hurting them. Run the math, and you get a body of roughly 5 times the mass of Earth, a few hundred AU out, taking something like 10,000 years to go around once. It got a name before it had a photograph. Planet 9. And we have never seen it. Not once. Every survey that could have caught it has come back empty. The search area is enormous, and it spends most of its orbit at the far end, where it is faintest. But that pattern was measured on 6 objects. We now know of more than 40 that far out, and as the sample grew, the alignment faded. The most recent surveys find them spread almost evenly around the sky. The clustering may have been an artifact of where we happen to point our telescopes. And there is a published paper proposing something stranger, that if it is real, it might not be a planet at all. It might be a primordial black hole, about the size of a grapefruit, with 5 Earths of mass folded inside it. We do not know. There may be a planet in our own solar system that no human being has ever laid eyes on. Here is how far out that search has to reach. Sedna, found in 2003. At its closest, it comes in to 76 AU, already nearly twice as far as Pluto, and at its furthest, it is more than 900. One orbit takes about 11,400 years. The last time Sedna was where it is now, there was no writing and there were no cities. And the only reason we found it is that we happened to be looking during the short stretch when it is close enough to see. There are almost certainly others out there we have simply missed. Which brings us to the headline you remember. In 2012, the news said Voyager 1 had left the solar system. Here is what actually happened. On the 25th of August 2012, at about 121.5 AU, Voyager 1 crossed the heliopause, the surface where the wind coming off our sun finally loses to the gas between the stars. That is a real boundary, and it is a genuine milestone. It is not the edge of the solar system, because the sun's gravity keeps hold of things far past where its wind gives up. Voyager has not reached the Oort Cloud. At its current speed, it needs roughly another 300 years just to arrive at the inner edge, then about 30,000 more to pass through. It has been flying since 1977, and it is not 1% of the way out, and it is still not the edge. The Oort Cloud is the strangest thing on this list because no one has ever observed it. Not once, not with Hubble, not with Webb, not with anything. Everything we think we know about it is inferred from where long-period comets turn around. You track one coming in, you run the orbit backwards, and they all seem to fall from the same enormous shell. If it is real, it starts around 2,000 AU and reaches out to 100,000. That is a bubble more than 3 light years across, wrapped around every single thing you have seen so far. And the pieces in it are roughly mountain-sized, sitting about 50 million times further apart than they are wide. This is the outer boundary of our solar system, and it is a structure we have deduced but never once looked at. One more thing about that shell. About 70,000 years ago, a star came through it. A small red dwarf with a brown dwarf companion, passing within about 0.8 of a light year of the sun, roughly 52,000 AU, straight through the outer Oort Cloud. That is 5 times closer than Proxima Centauri is today, and no other star is known to have come nearer. And here is the part that should stop you. There were people here. Anatomically modern humans, alive, outdoors, looking up. It was too faint to be much of a sight, a dim red point that may have flared now and then. But it happened. It is in the record of our own neighborhood, and somebody was standing under it. And we are about to find a great deal more of it. The Vera Rubin Observatory in Chile has a camera built to photograph the entire southern sky every few nights for 10 years. Every moving point it catches gets logged. It is expected to multiply the number of known objects in the outer solar system by an enormous factor, more Sedna-like bodies, more dwarf planets, and, if it is out there and bright enough, possibly the planet we have not been able to find. The map of the edge of our own solar system is about to be redrawn. So where is the edge? The wind stops at 120 AU. The gravity does not let go until 100,000. The furthest thing we can point a camera at is a few hundred, And the outermost structure of our own solar system has never been photographed by anybody. You did not grow up with a wrong number. You grew up with a wrong picture. And this is what is actually there.